Hi guys, welcome back. It's Nick here, back again with another episode of our transport game in Unity 5 series. This is episode 24, so this is the final episode of series 1. And what we're going to do today is fix up some of the bugs that we've sort of accumulated over the course of the series and just fix up the game really. So a lot of you might have wondered what really happened with this series. I realise a lot of you don't really care, so I made a separate video. Keep an eye out for that. Should be up there somewhere. Go have a look if you care about sort of what's been going on in my life recently and why these videos haven't been coming back. But anyway, back to what you're actually here for, which is the code. So a couple of things have happened with the project since I last made a video. I've upgraded my Unity to 5.3.4. It's not quite the latest at the time of making this, but it's just an upgrade that needed to happen. And there's a few sort of errors. So if I play the game, generate some terrain. So here we are, we're in our world. You look around, we've got these nice generating world terrain tiles, which all tile up, which is great. And we've got the trees as well. This is where we left off. But one of the problems you would have noticed if you're following along is the terrain modification stuff that we did quite early on no longer works with this new system. And the reason for that is because it relies on there being one terrain at all times, and we've got 9 in this setup and it doesn't know which one to pick. So if you start doing this, clicking on the terrain, which would usually raise it up and modify the terrain, you now get this little error, argument exception x or y base out of bounds. And that's one of the things we're going to fix. So I'm going to jump right into the code and go straight in. So I'm back in the terrain manager.cs file, and the first thing I'm going to do is modify some of these variables up the top. So there's a few up here: main terrain, resolution x and y, and heights. These are related to us having one main terrain and no sort of dynamic terrain system. So I'm going to delete these straight up and just ignore the fact there's going to be a few errors for now. I'm going to go down and fix those later. And I'm also going to go down to this chunk size x and chunk size y and just change those to be const. And the reason for doing that is because these values don't change. It helps the Unity compiler know that these are constant values, and it will replace all the values in our code with just numbers. So it saves doing the calculation. Say for example, chunk size x, throughout the code we're using chunk size x divided by 8 divided by 2. It now doesn't need to do that in the game because it already knows the value of chunk size x. So before you play your game, this will be replaced by the actual number. So chunk size x divided by 2 will be what, 256. So that'll just slot right in there. No need to do the division in the game. So it saves us a bit of time. Not much, but every little helps. The other thing I just did was delete a load of variables. So I'm going to go through and replace those references now. So in our start function, we've got a few errors. This was just initializing those values. So as we're not using them anymore, I can just straight up delete those lines, nice and easy. Scroll down. So in our modified terrain function, we're referencing this main terrain variable and also these resolution values. So what I'm going to do is I'm going to make a couple of helper functions to help us work out what terrain we want to get when we pass in a world position. So this function takes in this position value. I'll zoom in slightly so that you can all see. What we want to do is create a function which returns a terrain index. I'm just going to call this get terrain from pos and pass in our position. And this will just get the terrain from our world position that we've made. It's going to give me an error because that function doesn't exist. Did I spell that right? Oops. There we go. That's spelled the same, and then once we've got that, we can say terrain main terrain is equal to chunk graphics at terrain index. Terrain index. There you go. Can't spell. You guys are used to that by now. So there we go. So we've got our main terrain, and these errors are now disappearing. The other thing we want to do is get the position of the point relative to this terrain. So what that means is we're taking the world point and turning it into a point within our terrain. Rather than being, say, 100, it might just be 50 because it's only halfway through the terrain. But it's based on where the terrain is in the world. So this is another new function I'm going to make. I'm going to call it get relative position. You don't need to tell it which terrain to use, as all of our terrains are the same size, so I can just pass in position, and I'll just use that to update the value of position that we've already got. So another one of these is resolution. So to replace this, I'm actually going to use the chunk X and chunk Y values. So the resolution of our height map, if we scroll back up to our start function, when we look in our terrain data, the height map resolution is set to chunk size X divided by 2. And remember, chunk size X and chunk size Y are the same. So we don't really need a resolution X and a resolution Y. So I'm going to replace this with something called a property, which is very similar to a variable, but I'm just going to define it as a value that's based on a calculation. And my one's going to be read-only, so no one's going to be able to change the resolution of our terrain. So the way you do that, I'm going to say public int resolution, and then I'm going to do something a bit weird, is put some function brackets here, and type the word get, and some more function brackets. So what this means is, whenever someone tries to get the value of this variable, it's going to run and return whatever's in these curly braces. So put return chunk size X divided by 2. And because of what we said earlier, and turning it into const, this will become just a single number. So in our case, it's 256. It hasn't got any set function within it. So if you wanted to set the value of resolution, you'd have set like this, because that doesn't really make sense in our case, but you could do that. Right, so now we've got that, I'm going to replace all instances in our code where it used to reference resolution X and resolution Y. It's going to turn them into just resolution. So there's quite a few here. Some up here in modified terrain. Yeah, okay. So that's all of those resolution errors gone. So we're making good progress. We've got rid of a lot of the problems. We've created some new ones, but that's the way of code, isn't it? One of the last variable errors we've got is this heights parameter. So I'm just going to redefine that with the terrain that we now have. So I'm creating a new two-dimensional float array like this, call it the same so everything syncs up, and that's going to be equal to main terrain dot terrain data dot get heights. And to get this, you just pass in the X base and Y base. This is an offset within your a terrain to start getting the heights. Do 0, 0, and then just pass in the resolution as the width and the height. And that's going to get us a list of all of the height values across our terrain. So yeah, that's fixed all of those height errors. So now we've just got one last thing to do, or two last things I should say, which is to fill in these two new functions that I defined up here, but I didn't actually make yet. So let's just scroll down here and make some space. So we're going to do get an index into our terrain array. So it's an integer called, what do they call it? Get terrain from pos. And that passes in vector3 position. There we go. Okay, so that should make that warning go away, that error. Yeah, so that one's gone. And the other one that I need to make is convert world position to terrain position. And what did I call that? Get relative position. So I'll just paste that in as well. So it's going to return a vector3, get relative position, and it's also going to take a vector3 as input. There we go, so that's 2D functions. So let's start filling these in. So to get the terrain from the position, we want to find out what the x and y index is in our terrain grid of 9 values. So they're arranged in a way. And then we can use that to determine where in the list the terrain actually is. So I'm going to create a variable called x value and a variable called y value. Remember that the z value is up and down in this case, so we're just going to ignore that when we're talking about indexes into a terrain array. So the terrain array is 2D, it's not 3D. And these values are mathf.floor_to_int. And what we want to do is take the position.x and divide it by the chunk size y. So what this will do is it will work out how many chunks you are along in the x value, be that positive or negative, and then just round it down to the nearest one. So what we're going to do is just copy that up. So we've got the same thing for the y value, so it's literally the same thing, but taking in position.y and divided by chunk size y. That just gives us our 2 positions. Then from that, what we want to do is look at all of our terrains and work out which one matches those 2 positions. So I'm going to create a new for loop for I equals 0, I is less than the visible chunks dot length, and I++, there we go, basic for loop, and we just want to check to see if visible chunks I dot x is equal to the x value and visible chunks I dot y is equal to the y value. And if those 2 things are true, we found it, great, return I. If those things are not true, then something has gone very wrong. We're trying to find a position for a terrain that doesn't exist yet. So for now, So for now, what I'll do to solve this is just do throw new system.exception, and I'm just going to put in here could not find that chunk. There we go, exclamation mark. And now just throw an error message onto the screen and things will go badly wrong. But if this happens, then something else has also gone badly wrong. So we need to let the person know that things are on fire. Come and fix them. Get relative position is going to be a bit simpler than that. So the relative position is, instead of taking the floor value of a division, is going to do the same sort of division, but do a modulus. And what modulus does is it gets the remainder when something is divided. So if your chunk size is 500 and you've got 505, it's going to give you 5 because that's what's left. So I'm just going to go return a new, do it all in one line, create a new vector 3. So the x value is equal to modulus. How do you spell modulus? Modulus. No U. No O, sorry. And we can pass in position.x and chunk size x. And then for the y value, do position.y, because the y position doesn't matter in the world, because that's out of down. And for the z value, we're going to do position.z, chunk size y. So I think in hindsight, it was probably a mistake for us to use the y and z values interchangeably between our code and the actual world. I'm just going to leave that for now. I think it might cause us some problems later, but for now I think it works out all right. So some of you might have noticed that modulus in fact doesn't exist. It's not actually a system function, and the reason for that, this episode is kind of a little bit of a lie. I've recorded it in the past and it didn't go so well, so I'm re-recording, and I found that the modulus function that comes by default does have a few problems when going into negative numbers. So to solve the problem, the thing to do is create a new function called that returns a float called modulus, which takes in a float, float1, and a float f2. So these are our two input values. And what this is going to do is calculate the remainder. So first of all, you just do, so we take float1 and subtract it to float2 times math.floor float1 divided by float2. So the floor is the number, as we saw before, it's sort of the amount along that we are. So if you're 500 out of 500, you can get 1. We're going to subtract that from float2, which is our denominator, which gives us the exact whole number that we are along when we do a division. Then float1 minus that value from the division gives us whatever's left in float1, which is the remainder. So it's just a quick function for that. And I think that is about it for fixing up the terrain manager. So I think it's time to see if any of that actually works. No errors so far. And there we go. So I doubt it's surprising to you guys, seeing as I've just admitted to you that I've already done this code. But we've got our moving terrain function back, and we're getting no errors out, which is great. The only problem we do have with this, I think, is, yeah. So as you approach the edge of the terrain, when you border onto the next one, it is going to start having a few issues when you transition between the two terrains. So as you can see, some of the terrains do become out of sync, especially on these edge cases. But I think that's enough to finish up episode 1. There's only one last thing to say, and that is back at the beginning, we noticed that in some of these files we've got some compile warnings. Okay, so I've just done a quick re-import of these files because I know where they come from. So we've got these compile warnings, but you'll notice they're in assets, then standard assets. And the reason for this is we've upgraded our Unity version, so a lot of the core code that we would be using is a little bit out of date. So a quick thing for you guys, if you ever upgrade your version and you want to make sure your standard assets stay up to date, just one less thing to worry about, what you need to do is go back up to the assets menu and import package, and then find the package you wish to update, which is in our case utility. And instead of having the add button, it will have this little refresh icon, and that just means the package has been updated by Unity with the new values. So I click import, what it will do is go through and replace that old package with the new version. So all of these files are now updated, and the compile warnings have disappeared. There's no warnings there. So that's just a quick one for you guys. It's good practice to keep all of your standard assets up to date with the engine version, even if you created your project months ago in an old version. And with that, I'm going to say goodbye for Season 1. In Season 2, we're going to look at doing the actual gameplay for this. So I'm going to start us off with splines and doing networks and pathfinding. And I look forward to seeing you there.